Hello, it's David with Oklahoma Ham Radio, the YouTube channel. I am in the process of building out the loop, magnetic loop antenna. My goal is, 80 to 20 meter bands. I don't think I'll get there. It'll probably be 40 and 20 or 40 and 80, most likely 40 and 20. So, this is the third in a series of videos that are all in a playlist on YouTube on my channel. Stick around and check it out. Hey, if you don't mind, do those YouTube things, like, subscribe, click the bell, all that, so that you know when the next video in this series gets posted. Thank you, 73s. So I've put a lot of work into this. I say a lot, it's not that bad, but anyway, a lot of work into this little board here over the past, week or so. And where I'm at, I've got these little toroids right here, and I need to get them mounted. I've got 3 that need to go on, and they go on over here on this side. It's very important that you get those aligned right. So I've got this manual that I printed out. It's a good manual, and he did a great job. But in this manual, there is a picture of mounting those. It's on page, I don't know. There's no page numbers, but anyway, it shows right over here the direction, the orientation that you need to get those mounted at. So I think I'll do that this time. When I originally mounted them, I mounted them wrong. Then when I went through and reviewed, I realized, yeah, you messed up, Dave, so go fix it. So these are surface mount components. So if you've never worked with surface mount components before, there's multiple ways of putting these on. I don't have any of my paste. The paste that I have is old. So I do it with normal old solder. So these are just little toroids. Obviously, you got to make sure you get the right one, but these toroids are marked. And I feel like I'm going to drop it, and I don't want to do that. So these toroids have a little mark on them, a little dot, and you want to make sure that that dot goes in the correct direction. So to mount these surface mount components, what you can do is start by the equivalent of tinning these pads. Tin them, really you just want to tin one of them to start off with, and then you set this guy on top of it. All right, and then just heat that solder that you just put on that pad. All right, now that that one's heated on there, this should not move all over the place. Now you can go back and heat the others, get them to stick. This is your voltage regulator. When I mounted mine, I don't think I left these legs long enough, so I may be replacing this. I hope you can see that. Basically what the instructions tell you to do is to leave it long enough so that you can mount it to the bottom of the case in order to allow the case to dissipate some of that heat. That's a little thing to pay attention. Make sure that when you put your diodes in, you match the lines on the boards. And this capacitor, this potentiometer up here, you just, yeah, I didn't have any problem getting it in at all. It wasn't complicated at all. You just don't want to overheat it too much. So I think I'm done with this board. Let me pop the little Teensy controller in here. That Teensy is you want to orient it so that the port that's on the back goes to the back of the board. Snap that thing in there. Make sure it's lined up well. And push in. And then I've also got the motor controller. The motor controller, if you look in the documentation, it's the best way to identify which direction to put that in. Right here on the board is that motor controller. You'll see that potentiometer is up on this end. So I'm going to align it to where that potentiometer is up on that end. Also, in looking at the board, I see which pin is marked as number 1, which I believe is basically on the same side as the motor or that potentiometer. So that matches the notch. So U2 is where we're putting this in. So I do believe that's the right direction. I think I'm done with this board. Done building this board anyway. Unless I need to replace that potentiometer. I'm sorry, that voltage regulator at the bottom. I do have another one. I do believe this is correct, so we'll find out. So the next part is this SWR meter. There are a few things that you have to do a little bit differently from the normal kit build. All of these are outlined in the instructions, and I hope I got them right, but one of them in particular I want to talk about. So you change these capacitors to different values, different value capacitor. Let me see if I can get that in focus. Okay, we'll do it up here. Does not want to focus either. This board evidently is difficult to focus on, so we'll do the best we can. So these capacitors you change out to different value capacitors. You wrap these toroids with more wraps. You eliminate some things on this board, particularly a couple other capacitors. I even think that these resistors are changed out with some larger value resistors. But the one that's interesting is you short, it's called shorting the potentiometer. And I did some research on that. And what that basically is doing is turning the potentiometer into a variable resistor. And from the research that I did, if you do this research, you'll find out that a lot of companies do that because basically, even if this this resistor, which a potentiometer is a resistor, fails, then you still guarantee that you don't blow up your electronics, because it won't ever go over the max, right? So these are 50 kilo ohm, yeah, 50K potentiometers. You won't exceed 50K no matter what. So it prevents things from getting messed up. In the instructions, it also says that, you know, pay attention to these pins versus what's on the board, because they don't line up exactly right. You'll need to adjust your wires to account for the difference in the way that these pins are lined up. So overall, this was not a difficult build at all for the SWR meter. The the other device was not that difficult either. I found it enjoyable. I'd say it took a couple hours just to make sure that things are right. There's really nothing else that you do on the LCD panel. It's normal, you don't modify it in any way, no pin adjustments, nothing like that I've found yet. So yeah, overall pretty simple. It's just the potentiometer. So the next thing that I'm going to work on this morning is out on the drill press. So I've got to take this box, and I've drawn out on it where I want things to go. And on the back, I've drawn out where I want things to go. I am putting power poles in here, as opposed to, just a normal, round barrel connector or anything like that. So those power poles hopefully will make it a little easier to put in the shack. I do have a power switch, a little DB9 connector that'll be used to connect to the wiring going to control the motors. And then I opted for SO239, I think, connectors, the larger connectors on the back. I don't have one on my desk, which is very odd. The panel will go here. Potentiometer, there are 4 buttons and a switch. So I've got to go poke holes and cut out some stuffs. And I don't have, actually on the inside here, I did mark where the boards will go on the inside. So I'm going to go try to poke some holes here and see if I can't prevent messing up this case. And go from there. 73 guys, I'll throw another video out after I finish poking all these holes. Actually, I'll tell you what, instead of throwing out another video, I'm just gonna add to this video. So this will be a long one, all good. Hopefully you guys stick around and watch it. Thanks. I was gonna go outside and work on that, but you know what? Let's see, how many minutes? There should be a YouTube video on that I want to catch. Not the one I thought it was. So let me go see if I'm missing that. I think it started 4 minutes ago. I think it's coffee and ham radio. So I'm gonna go check that out right now and come back. This is the Skull Shaver. It's pretty cool. It's a Bulldog Platinum. So it's got a little power button on top. Tells you how much use is left. Here is the before. So let's do this. Here is the before. And we're going to go ahead and get after it. Let's go ahead and do it this way. Now you can use this on more than just your face, used on your head, whatever, right? So, I figured I'm not monetized, so just to make you guys feel better, I'm including this video. This portion of the video, anyway. So does it work in the shower? It does. I'm not gonna jump in the shower and use it and show you. But it does do a pretty dang good job. All right, back to the video. This is my coffee maker. It's a Brun. It'll make you happy. It helps you make coffee and other things. Like tea, there's always hot water. It can be plumbed, in fact, needs to be plumbed directly into a water line, so you don't have to turn around and fill the top of the coffee pot. This is my coffee. There's some in there, in a coffee mug. You should drink some. It'll make you happy. So I've built the cubicle quad magnetic loop antenna, and there's a couple things that I discovered when I was building it. I just want to talk about some of these. So this is a balun. That balun is a 1-to-1 balun. You do have to take the ground from both sides of the loop around to ground on the antenna coming down. Right now I've just got this loop held up with some zip ties, but I did do a double loop configuration, passed underneath the capacitor there and went back around. So I'm looking currently for a better way to mount this. I don't know what I'll do there yet. Better way to mount this. Right now it's just sitting out in the garage on the ice chest, but I do want to show you some results that I'm getting here. So there's Nano VNA hooked up, and as I turn the potentiometer, the variable capacitor here, you can see it can go up the band, and this is how much I'm turning it. That far. See if you can see that. That far, moved it that much. So it's very, very fine adjustments here. But we can go ahead and turn it more freely, shoot all the way up. This is the 80 meter band. So what I'm gonna do is get up here to the 40 meter band. Well, let's see what we can do on 60. So that's 80. I think 60 is like 5.3 something. So let's go ahead and jump up here to a different sweep area. Let's go from 5 to, I don't know, 5.5. Sorry for the munching there. My granddaughter is out here with me and she's eating pickles. So I'm gonna keep turning this and see what we can get up here for the, see when it comes in. Okay, so it's about to come in. It'll come down on that huge spike, but there's the 60 meter. Well, this hole, somewhere in this range is the 60 meter, right? So about there, and I'm turning this quite a bit now. So now let's get up to the 40 meter band, which I think's about 7.3 roughly. So let's go to 7. I don't know, let's do 7.5. I think it's roughly in that range, but we'll go ahead and turn this knob and watch this come up. It's about to come in. Oops, it's already there. I went too quickly here, so I'll come back with it. I don't know, there's 7, and we'll get over, I think it's like 7.3 roughly. But anyway, you can see it'll work in that band. So now let's go up to, let's see, that was 40. We can go to 30. I'm not familiar with the 30 meter frequencies. I think they're about 10. Yeah, 30's 10.1 to 10.15. So let's go on up to there. 10, let's do 9.8 to 10. Let's go 9.8 to 11. Just see it not flash by so quick, maybe. Let's let that come back. So there we go. So you can see we're, below 2-to-1 SWR on very sharp areas, obviously. And right there's 2-to-1 SWR. Just a little above 2-to-1 SWR. So let's go to, let's see if we can get all the way up to the 20 meter band, which is 14, I think. 14 megahertz to 14,350. I don't think I can make it there with this configuration. So let's do, let's just see, 13 to 14, oops, 14, 5. I think I'm just below it actually. Oh, yeah, I'm bottomed out right now. So let's see how low I can go. Yeah, I think what's happened is I need to fix this solder joint right there. Or it's just the fact that the capacitor is completely out of, which is entirely possible. See where we're at now. Maybe that'll do it. So it takes me right up here to 11.8, just under 12, which is nowhere, no man's land. So, in fact, let's go ahead and take 11 to 12, so we can figure out exactly where that is. Let's go 102. Yeah, so 11.89, 11.9, somewhere in there. That's nowhere, right? So I'm trying to figure out how to solve this. So I want to get up to 14. The capacitor is turned all the way. In fact, it's, see right here, it's open. And need to figure out how to get on 20. So my guess is reducing the size of that loop. That small loop may take care of it. The other thing is, in all the calculators, 17-foot circumference of a magnetic loop, 17-foot circumference, which is just over 6 foot in height, is okay on 14 megahertz. But I think what's happening is I've got this capacitor in here also. It adds another foot, which kicks it out of skew. So, or out of whack there. Let me see that tape measure, Roy.
Sure.
So this from end to end is another 10 inches. Roughly. So 17 foot 10 inch, 17 foot 10 inches total circumference. May need to reduce that to about 16 foot and reduce the loop up top by a little bit. Because as I've shown, I can get up to 80. I'm good with stopping at 80. But I'd really like to get 20. So maybe that's a thing I got to do. Also, I got to clean up my work area. It's kind of nasty. My shop vac is at my daughter and son's house, so we will have to get that so I can clean up my area. Plus, I've got boxes and garbage all over the place that I need to get cleaned up. So my granddaughter wants to say hi. She's out here in the garage making stuff with me. There's some stuff she's working on. But anyway, that's where I'm at right now. I do want to show you one more thing in the house. Go ahead and go in there.
Inside.
In fact, I think I showed it already in another video. I'll just include it there, but I'll continue working on this next weekend. 73s, bye.